Okay, well, we got through a lot of stuff there, so good job. You should be through graphing and speed, and now we're moving on to acceleration. So now you're going to need out your notes on acceleration. And yours are really more fill in the blank. So acceleration is another way to measure and describe the motion of an object. Acceleration is the rate of change of velocity over time. Now remember, velocity is speed and direction. So if something changes its speed, or if something changes its direction, it is accelerating. So an object is considered to be accelerating when it speeds up, slows down, or changes direction. Now, interestingly enough, you know how speed was measured in like miles per hour or meters per second. Acceleration is measured in miles per hour squared, or meters per second squared, or kilometers per hour squared. The reason that it's squared is because it is speeding up or slowing down over time. Now, an object can either positively or negatively accelerate. So if when you do the math, you get an example or a negative number, that's okay. No big shake. All you need to do is just realize that a negative acceleration is when an object slows down. Also, here is the formula for acceleration. Now I'm going to pause the video and I want you to look at the board that is in the lab setting, and I want you to copy the triangle into your formula page. I'm going to give you about 1.5 minutes to do that. Copy down all the things, because on your formula sheet, you'll be able to use your formula sheet on the test. Okay, so that triangle should be written in your formula sheet. Here's what I want to talk to you about. If you look at that triangle, I like the triangle the best. I'm not going to lie. I give you the triangle because I think it's easier to do than math. Because if you're going to have to multiply by t's on both sides and then subtract acceleration on both sides, maybe you don't even know what to do. I think the triangle is easy because all you have to do is put your thumb over the unknown and you just have to figure out the equation from there. Now, here are some examples, right? I'm not going to work these out because I want to work out your practice problems. You don't have to write these in. You can work them out on your own. I'm going to slowly scroll past these so you can just kind of see what it looks like. But then we're going to do some practice problems together so that you can see what I want from you. Okay. Okay. So all you need to do is scroll past those examples because I want to walk through the practice time ones with you. So when I do these, I just do some underlining because really this is about reading and just making sure that you pick out all of the things that you need to know. All right, so in this first one, a car accelerates from standstill. How fast is standstill? I can't hear you. It's 0. So it's going to be 0 kilometers per second to 60 kilometers per second in 10 seconds. What's its acceleration? So they're asking the unknown, which is acceleration. The formula for acceleration is A equals VF minus VI over T. VF minus VI is also known as delta V. The delta symbol means change in. So I want to know the change in velocity, which is final minus initial. So what was the final speed? Oh, it was 60. So 60 kilometers per second minus 0 kilometers per second is 60. And then I'm going to divide that by time, which is 10 seconds. 60 divided by 10 is 6. And then it has to have a unit, which is going to be kilometers per second squared. Okay, number 2. A car accelerates from 25 to 55 in 0.0083 hours, which is a really small amount of time. So now, what is its acceleration? A equals VF minus VI divided by T. So change in velocity. Final is the final 25 or 55. Car accelerates from 25 to 55, which means it ends at 55 miles per hour minus 25 miles per hour, all divided by 0.0083 hours. You're going to do the math, write your answer in, miles per hour squared. Number 3, a runner has a velocity of 11.1 meters per second for 9 seconds, which means they're able to run at 11.1 meters per second for 9 seconds until he finishes the race and comes to a stop. What is his acceleration? A equals VF minus VI divided by T. I need to know the change in velocity, so the final minus the initial. Well, his final is that he comes to a stop, which is 0, minus his initial, which is 11.1 meters per second, all divided by 9 seconds. You're going to get your answer. It's going to be in meters per second squared. And number 4, a motorcyclist has an acceleration of 5 miles per hour squared. If his initial velocity is 45 miles per hour, what is his final velocity after 4 hours? What am I solving for? Final velocity. So that's going to be a little trickier. Divide, multiply. I've got delta V up here. I've got acceleration and time. Now, when I'm going to solve for final velocity, what I'm solving for is this unknown. So I'm going to set up my acceleration times the time. I covered over that. Give me a second. So his acceleration is 5 miles per hour. 5 miles per hour times the time of 4 hours. Now you're going to get an answer there. 5 times 4 is 20 miles per hour. But that is not what you're looking for. What you're looking for, so this right here is the change in velocity. I want to know the final velocity. So if his change in velocity was 20, I'm going to take his 45, which is where he started out, minus 20, and I'm going to get 25. His final velocity after 4 hours was 25 miles per hour. That's a rearranged one, which is kind of hard. If you've got time, you're going to go to page 13 and do some practice problems. I did link a video on the slideshow if you want to watch that.